So from our last class, let's continue. We are solving this exercise 1K number 10. What I do is I used to look for the ones that are like the hardest. I'll solve them. So when you can, from there you can easily solve the other ones. Now they say the top of a building 24-meter high is observed from the top and bottom of a vertical tree. Now this is a building, and they say this building is 24-meter high, and there is another vertical tree somewhere. They say they observe it from the top of the tree and from the bottom of the tree. Now I can't do anything because I've not finished reading. When I'm finishing, I will know if this tree is higher or this building is higher. The angle of elevation are found to be 45 degrees and 60 degrees. Let me bring it closer. The angle of elevation are found to be 45 degrees and 60 degrees respectively. Now they say 45 degree first, 60 degree first, and the word respectively means, if you go back, they say is observed from the top and from the bottom, meaning this top we have 45 degrees and the bottom we have 60 degrees. Now the angle we use there is elevation, no more depression. Remember what I told you about elevation is upward angle. Now for them to say that you are looking at a building from a top of a tree at the same time from the bottom of a tree, but they say it's an angle of elevation, meaning you are looking upward, like the angle is going upward. It means that this building is obviously taller. So if I'm to sketch this, it will be something maybe like this, and then you look at it, because this is what we are observing. You understand? The top and the bottom. So they said from the top, this, okay, let me draw it now properly. We have the building. Obviously I know that the tree is taller and the building is taller, and now have a tree. All of them are sitting on one vertical ground, and they say that you observe this building. Let me still extend this thing. You observe this building from the top. Somebody stayed here and look at this place. The same person, or maybe another person, I don't know, stayed here and still look at the same. And this is a tree, and they say this building is 24 meters. Now we are told that the angle of elevation. Now the angle of elevation, this is a perpendicular angle. Here is 45 degrees from the top, and the angle of elevation, which is here, is 60 degrees from the bottom, and they say here is 24 meters. We are told to find the height of this tree. Now we've gotten what we want. We all know that here is 90 degrees. So if here is 90, here is 60, here will obviously be 30 degrees. Now look at what they told us to find here, this place. Now there is something I want us to observe. This is another twist to this question. Normally what I plan to do is to, because this 24 is here, I will first find this hypotenuse, then come here. But you can see, normally, we all know that our hypotenuse is usually the one facing 90 degrees if you are dealing with special angle sword. And here now we don't have any 90 degrees, because if you check it, if here is 60, since here is perpendicular, here will be 30. And if here is 30, here is perpendicular, here like this, and they say here is 45. So this total angle here will be 90 plus 45, which will be 135 degrees. And since this is a triangle, the total angle will be 180. So 30 plus 135, 165. 165 plus what will give you 180 is 15 degrees. Now if you look at this, you notice that, okay, first thing I'm supposed to do is, from what I think I will do is use this 24. I'll do something like sine opposite over hypotenuse. I'll find this and still use the same. Look at what I'm looking for, adjacent over hypotenuse. I'll now get this. But there is a problem. What is the problem? The problem is that here is no longer 90 degrees. So if I use that normal formula, I might be having an issue. So what I'll do is I plan to extend this thing. I'll do a virtual angle here, a virtual angle. So I have another triangle. So the best way to go about it is, since here to here is 24, Obviously, here to here is still 24. I'll look for this. And whatever I get, to get this, I'll subtract 24 from this and I'll get this. So from here now, here is 30, here is 15, so here is 45 degrees. And from here is already 90 degrees. So 90 plus 45, here too will also be 45 degrees. So this thing does not really have a formula, just understand it. Try to find a logic. I think this one is very difficult, so just for you to try to interpret it, have a logic for it. So first, let's start. Now I want to look for this hypotenuse, the one facing 9. So it will be opposite over hypotenuse, which is SOHCAHTOA, which is sine 60. Opposite over hypotenuse, which is 24 all over, let me call this x. So sine 60 is, are we together? So sine 60 is this, and sine 60 is 3 root 3 over 3. Let's do this so that we can solve this thing on one page. Let's do something like this. Sorry for being this thing being rough. So I will now say this is over root 2, 3 over root 2 equal to 24 over x. We do cross multiply. We have x root 3 is now, oh god, what am I doing? This is 2, not root 2. We now have 2 times 24, that is 48. So x is now 48 over root 3, which is the same thing as 48 over root 3 times root 3. Trying to take away the salt from the denominator. This times this, it will be 48. Okay, let me put it here. 48 root 3 all over 3. Oh my god, this my calculation is very, very rough. So this is over 3. 3 cancel here. 1, 3 cancel here, 16. So 16 root 3. So x is now 16 root 3. So this place is 16 root 3. First thing I'm going to solve, next thing I'm going to solve is to solve for this place, because I'll use this whole triangle here like this and solve for here. So whatever I get from here, I'll now use this smaller triangle and solve for here. Whatever I get from here, I'll now subtract 24 from it and get here. I know it's a very, very long process, but that's what we. So the next is so to get here, it will be this angle, which is 45 plus 15. This is 60. So I'll have something, let me sketch it out. I'll have something like this. This plus this 60, so here is 60 degrees. And here is already 16 root 3. And this is where I'm looking for. 60 degrees. So it will be adjacent over hypotenuse, which is what? Cos 60. So I'll have cos 60, which is x over 16 root 3. Okay, let me call here y so we don't repeat ourselves. I'll call it y. I'm looking for this place, so let's call here y. So cos 60 is 1 over 2. So I'll now say 1 over 2 is equal to y over 16 root 3. So when we do cross multiply, we have 2y equal to 16 root 3. So y now is divide both side by 2, which is 8 root 3. So in that case, I've gotten here as 8 root 3. Now I'm supposed to, let me now look for this height here. So in that case, I'm not dealing with this, just only this triangle. Only this triangle. So let me sketch it out. I have something like this. This is what I'm looking for. Let me call here z. Here is 8 root 3. And only this triangle here is 45 degrees. So here will be 45 degrees. We all know that here is 90 degrees. here to also be 45 degrees. So here will now be opposite of adjacent, which is tan. Tan 45 equal to z over 8 root 3. I've told you how I need to come up with one. Like here now, I'm looking for here, and I know I have here. I will try to link both. I've said this many times. So the closest one to link it is this over this, which is cos 60. Here now, I have this, and I'm looking for this. The one that will link this opposite and adjacent is tan. That's I'm using opposite over adjacent. So that's how you need to know which of the trig you will use. You now use the angle there and get your answer. So for this, tan 45 degrees is equal to 1. So you now say this one becomes 1 equal to z all over 8 root 3. So when you cross multiply, z is now 8 root 3. Now to find this height of this tree, we all know that from here to here is 24 meters, and we already know that here is 8 root 3. So to find here to here is 24 minus this. So let me call here, what would I call it? Let me call it W, which is the height of the tree. Or let me just write the tree is now 24 minus 8 root 3. So we will factor it out. It will be 8 into 3 minus root 3. This is a final answer. My work might be rough, but if you have any question, you can drop it in the comment section. So this is how to solve a word problem. Read it, try to understand it, picture it out, and be careful, pay attention to details, and then you solve and you get your answer. So the next topic, which is the last topic, is Pythagoras theorem. When I was teaching in the other class, I touched it. Simply, what it's trying to say is that when you have a right angle triangle, mind you, it always only apply on a right angle triangle. Don't use the Pythagoras theorem on a non-right angle triangle. If you have a triangle that is not a right angle, there is another formula for that, not Pythagoras. So you say in a right angled triangle, the square of the hypotenuse is equal to the sum of the square on the other two sides. Now, which one is the hypotenuse? As I said earlier, simply means the one facing 90 degrees. Then the other two sides. So the square of this, look at it here. The square of this is a pictorial example of it. This is the square of this is equal to this plus that. So I will not need to dwell too much on this. I'll just solve one example and we move. Let's go to this example 1I F. You have this. Let me picture it out. You have something like this and this and this. Also another one like this. This is what we are trying to solve. Now we are being told to look for x, right? You know that here is 9. Here is right angle triangle. Here is another right angle triangle. Here is 6 and here is 6. Now for you to look for this x, it says, you know, you are using Pythagoras theorem, where the square of here and here, I didn't write it out. If you have a right angle triangle like this, let's call here B, let's call it, and here C. I'm sorry, B, A, B, and C. It simply says that this C square is equal to A square plus B square. So in this case, we have this and that. So we are looking for this. But for us to solve for this, we have to make sure that we have to use this to calculate it. So for that reason, we don't have this, but we have the two sides of this right angle triangle here. So but we use this right angle triangle to find the hypotenuse for this, and indirectly use it to now find this. So here, let me call here x. So x square will be equal to 6 square plus 6 square. So x square is 36 square plus, 36 plus 36. X square is now 72. So x, when you find the square root of both sides, is equal to root 72. So x is now 36 times 2, which is the same thing as the square root of 36 is 6 root 2. So here now is 6 root 2. Now here is 9. So it is this 9 square, because it's the one facing 90 degrees. It is this place square that will be equal to here square and here square. So let's go to the second one. We have 9 square is equal to 6 root 2 all square plus x square. Now I can say, so I can rewrite it as 6 root 2 square is 72 square. From here we've already solved it. This is what we found the square root of this to get this. So I can just say, okay, 6 root 2 all squared plus x squared equal to 9 square. So x squared is equal to 9 square minus 6 root 2 all square. So x squared is equal to 9 square is what? 81. 81 minus, as I said, this is equal to this. 81 minus 72. X squared is equal to 81 minus 72. This is 81. This is 72. Take 1 here. We get 9. We are left with 7 here. So here is the answer is 9. X squared is 9. So square root of, we'll find the square root of both sides. So x is now 3. This is your final answer. As you can see, I just jumped straight to the answer, to the exercise of Pythagoras theorem. I didn't bother to teach it because we've done it in our last class. Pythagoras theorem is simply saying that when you have a right angle triangle, mind you, only apply to right angle triangle. Here is A, B, and C. The square of the hypotenuse is equal to the square of both sides. So you can use this formula to find for this. In this case, C now will now be equal to square root of A square plus B square, right? This is this hypotenuse. To look for it. Then to look for B, it will be C. Let me say A square plus B square is equal to C square. So B square is now C square minus A square. So B is now square root of C square minus A square. In the same hand, if you want to look for A square from here, when B go to the other side of the equation, you can say A square is equal to C square minus B square. So A square is now C square minus B square. This is just a summary of Pythagoras theorem. So this is all for it. If you have followed me to this point, just know that you are done with chapter 1. This is chapter 1, swords, and chapter 6. In the process of doing chapter 1, we transverse into chapter 6 when we are doing the trigonometry. So thank you and see you in the next class.